So again, stoichiometry in chemistry involves the calculation of the quantities of reactants and or products in a chemical reaction using the mole relationships that we find in the balanced chemical equation. So in a balanced chemical equation, such as shown in this box, you see the red colored numbers that are placed before the chemical substance's chemical formula, and these coefficients represent our mole ratio. So if we're going to translate the chemical equation, the balanced chemical equation here into a statement, so we can transform it into like this. We can say 1 mole of N2O3, then the plus means reacts with 1 mole, so another 1 mole of H2O, and then the arrow means to yield, or the other synonym for that is produce or form. The products which are, or the product which is 2 moles of HNO2. So I have to fix this one also. That should be HNO2. So the product is HNO2. So this is now the statement of our balanced chemical equation. So if we look at the other examples below, we are given another set of balanced chemical equation. So it says here, let's indicate the ratio of compounds that are involved in the following boxed balanced chemical equations. And let's write our answers inside the box. So this is very simple. All we need to do is mention the mole ratio that we find in the balanced chemical equation, and you don't have to balance anything here. The equation is already balanced. So let's write the statement in this case. So we have 2 here. So we'll start with 2 moles of C2H6. So 2 moles of C2H6, and then the plus means reacts with, then we see 7. So 7 moles of O2, and then arrow means to form, or to form, to yield, or to produce. 4, so 4 is the first product, 4 moles of CO2, and then plus means and, so and 6 moles of H2O. You may, so I will consider, you may use the chemical formula of the substances, or if you're comfortable naming them, that's all right. But it's also all right to just stick with the chemical formula of the substances. You may also write the word for the number, so 2, or you can also use the number 7 like this, or the word 7 for that. So let's begin with our very first conversion here, the basic stoichiometry, which is what we call the mole-to-mole conversion, the first part of our stoichiometry lesson. So as always, in a certain problem, you are given the balanced chemical equation here. So we have N2O3 plus H2O forming 2HNO2. The question is, using the balanced chemical equation below, which is this one, how many moles of HNO2 are formed if there are 2.00 moles N2O3? So the first thing you need to do is encircle or highlight what you are asked. So HNO2 is the one being asked, and what you're given. Okay, the given is 2.00 moles N2O3. So the first is, I placed here a format on a chart form so that you know what's first, what's second, and what's the answer after that. So the first one is you put the given first. So the given is the one with the number. So the given is 2.00 moles. So I'll just use the abbreviation of moles, MOLS. And then you put the substance. It's very important that you include the chemical formula of the given substance, okay? Then after that, the second one after the given is mole ratio. So mole ratio of the coefficients of the given and the required. The given is N2O3. So this is our given. And the required is HNO2. So this is what we are solving. So I put a question mark. So I am going to use the mole ratio there. by default, the operation is always multiplication there. And then we put our mole ratio in a division format. So you put a line there. And then the one below should be the N2O3 because we want to cancel it. So N2O3, what's the coefficient here? We don't see anything. So that means it's 1. So 1 mole N2O3. And the one on top is the one we're solving, which is HNO2. And the coefficient is 2. So therefore, I put a 2 there. So 2 moles HNO2. Then when I place there, it's very obvious that I can now cancel moles N2O3, and the mole N2O3 there, because this is conversion. So we should cancel the unit of the given using the coefficient mole ratio here and arrive at our answer. So this is now the simplest calculation of the mole-to-mole conversion. We're just using the mole ratio from the balanced chemical equation. And now we're ready to calculate that, so we now put our answer. So the ones on top are multiplied. So 2 times 2, that is a 4. And this one means divide. So 4 divided by 1 is still a 4. So the final answer is 4. We stick to the significant figures. So you put 0.00 to stick with the 3 significant figures in the given. So 4.00, and the unit should be whatever remains on top, which is also the question from the problem. So 4.00 moles HNO2. And that is our final answer for this mole-to-mole problem.